I'm Nick Piper, a third-year biochemistry major here at Cal Poly in the class of 2017. I'm a learning assistant here to help you make some awesome graphs to go along with your lab reports in the general chemistry series. So, I will cover what a good graph looks like and its graph anatomy, what a bad graph looks like, and I will also go over how to make an example graph. First, we'll go over how to make a good graph. This top graph is an ideal graph based off of some random data that I made up. It has 6 key and essential parts. 1, it has a good title. So this title is descriptive. It tells you something about the graph. It tells you that it demonstrates graph anatomy. It serves no real purpose. And it's not X versus Y or Y versus X. So it's descriptive and good. Then you have the axes labels. This is the y-axis, the x-axis, otherwise known as the ordinate and the abscissa. On the ordinate, you always plot the independent variable. This is what you read from your experiment, your readings, and then this is the dependent variable on the x-axis, or abscissa. This is the variable that you change in the experiment, whether it be concentration, temperature, etc. And then here, since we have 2 data sets, we have our legend. Whenever you have whenever you have 2 data sets or more, you normally include a legend so that you can differentiate the data on your chart and read it properly. We also see that we have trend lines here. These describe the data sets, and these are curves fit to the data set so that we can use these equations for predictive power to say, hey, if we know this y, we know what the corresponding x is. So we know at like 270, it's going to be somewhere around 7.75. And then moving on, grid lines, or lack of them. In this good graph, there are no grid lines, so vertical or horizontal lines like down here, that kind of obscure the 6th part of the graph, the field of the graph, which is basically this blank space where the data is plotted. As you can see, the field is actually kind of the most important but least paid attention to part of the graph. As you can see, the data fills up all of the field pretty much, and you see all the intricacies of the data, the ups and downs. You can see this quite well in the field of the graph. Next, we'll move on to what a bad graph looks like. We'll go through the title, axes, legend, trend line, grid lines, and field of this graph down here. So first, let's take a look at the title. It's very short and not very descriptive. Y versus X. It doesn't tell us very much. What is Y? What is X? It could use some work. Moving on, the axes label. There is none. So clearly, this graph doesn't tell us anything. It just tells us numbers related to numbers, and they have no units. They have no meaning to us as a reader of them. And then another issue, moving on to the legend, is that we have a legend. There's only one data set plotted on this graph. So if we know what that one data set is, we shouldn't have to have a legend. So whenever you're plotting one data set, do not have a legend. And then we'll look at the trend line here. Oh man, this is horrible. Look at it. It's not matching the data whatsoever. It has no predictive power. If we were to take a reading at 600, we'd say, oh, it has a value of 10, whereas it really has, a value of, I don't know, it'll be somewhere up here in the 600 range, maybe 14. Also, this trend line, the equation is like way off in the corner of the graph, and it's really tiny, and no one can read it, so it's not of much use there in the corner. Then we'll move on to the grid lines. Always in your chemistry classes, do not include grid lines. They're ugly, they're despicable, they just don't look good. Keep your field clear. And moving on to the field, now that we mention it, all the data is in this one little corner here. Our field should be filled up. We should be able to see and visualize all the data like in this graph, the good graph up top. But here we can't really see anything going on. So that should be something we should try and fix. All of these issues can be solved through the formatting bars at the top, which we will go through later when we are making the example graphs. We're going to now go over how to make an example graph with two methods, and first we'll go over the awesome way. This example is from Chem 127. It's the absorption spectroscopy lab, and we're looking at the calibration curve for red food dye number 3. The data was measured at 530 nanometers. That was the lambda max. And we have our concentrations calculated from our dilutions and our stock solution concentration and our absorbance here. And we are going to be looking at absorbance versus concentration and use Beer's law to make a useful calibration curve for this. So first, for the awesome way, we will select our data that we want to go into the graph, which is the concentration absorbance. We'll highlight it, and we will go to Insert, and then this little chart down here. We'll click on it, it drops down, click on the scatter plot, and we've got a pretty nice chart here. Skipping ahead to get some of the heavy lifting out of the way, we're going to get rid of these grid lines, format grid lines. Just right click on the grid lines themselves and click Format Grid Lines, No Line. Get rid of them. Format these grid lines, the vertical ones, No Line. Get rid of them. Awesome, now we have an empty field. Also, let's check to make sure that our data was plotted properly. Here on the y-axis, or the ordinate, we've got 0 to 1.6, so our absorbance runs from 0 to 1.3. That looks like it's on the right axis. And then 0 to 20, and our concentrations go from about 0 to 20 on the x-axis, so it did plot properly. Now going on, let's edit our chart title and put in something a little bit more descriptive. This will be the calibration curve for red food dye number 3, measured at 530 nanometers. So that's a pretty spot on title. Going on, we will label our axes to make this graph a little bit more useful to us. And let's go for the vertical axes first. This will be absorbance. And the units are AU, absorbance units. And then we will click out of there, and then we'll look at the x-axis, or the abscissa, and we will add concentration with units of micromolar taken from our data. And we've properly formatted our labels here. Now let's move on. We don't need a legend because it's only one data set. And let's add a trend line. So you'll click on the data points, then you'll right click, add trend line. We want a linear trend line for this graph, so we'll keep it with that. And we'll want to display the equation on the chart and display the r-squared value on the chart. Cool. Now we click on the equation box, go home, and we'll format this. We'll click on this big A, and it will increase the size of our equation so we can use it later. Now moving on, we've got our trend line, we've got our equation, our grid lines are gone, and our field is nice and filled up. A good descriptive title, we can make this a little bit larger, maybe blow the chart up a little bit, and that's a pretty good looking graph. Next we'll move on to the super awesome method of making the graph. Now we'll go over our super awesome way. So to make this graph, we will select our data again. We will get an insert and this big button, the recommended charts button. We'll click that and we'll choose scatter with straight lines and markers. Unfortunately, none of the options here are just scatter, which we'd rather prefer, but we will choose this one and just modify it later. Sometimes it does pop up though, so let's go with this. We'll make it a little bit bigger to work with, and let's just start off by getting rid of the grid lines. Format grid lines, no line. Format grid lines, no line. And now we have this awesome graph. Let's right click on that line that we have in the graph and change the chart type. And we'll just go down, XY scatter, click on scatter, and we're basically back to where we were starting with this guy. And we'll add the trend line first here, Why not? Linear display equation on chart, display R squared value. We'll click on the box here, go to the home button, increase the size of it, maybe move it a little bit more towards the center, and let's modify our title here to the calibration curve for red food dye. Number 3, measured at 530 nanometers. Cool, nice title. Let's add the chart element of the axis title, the horizontal one first this time, why not? Go for a little bit of variety, concentration again, and micromolar. Versus concentration on the abscissa, and then on the ordinate we will put absorbance again, which is in absorbance units, AU. Alright, and our field is full, our trend line is added, our labels are added, we have a good title, and we have no legend because there's only one data set. So that's how you make a chart the super awesome way.
My mama cooks in Italy, and mama swims in Argentina, mama's got a chunga, yeah. My mama's working